This lesson today, we are going to show you how to convert the forms of linear equations to the other. So we're going to convert from slope-intercept to standard form, and we're also going to show you how to change from standard form of a linear equation to slope-intercept form. First of all, just a quick review. Slope-intercept form on the left, the standard form is y equals mx plus b, which we've all seen a lot. And an example of that would be y equals 2/3 x plus 4, where the slope is 2/3 and the y-intercept is 4. Okay. Now, standard form has a few restrictions or requirements to make it a good standard form. The form in general is ax plus by equals c. But to be written properly, first of all, notice that both the x variable and the y variable are on the left side, and the constant is on the right. Now, further restrictions are that all three of the coefficients or constants have to be integers. Okay, all have to be whole numbers basically, and a has to be positive. Okay, a has to be positive. So if as you write these equations down and you collect your terms on where they're supposed to be, and the a term, the coefficient of x, turns out to be negative, you just have to multiply the equation by minus 1 to change all the signs and get a back to a positive. An example of a standard equation is 3x plus 5y or minus 5y. In this case, 3x minus 5y is 15, which is somewhat similar to one of the earlier equations in a different lesson. But notice that the a coefficient, the 3, is positive in this case. Okay, so let's take a look. Let's move on here. We'll take a look to convert. Now let's take the example equation that we had, y equals 2/3 x plus 4, and convert that to standard form. The first thing we want to do is we're going to get rid of all the fractions in this equation because we have to end up with whole numbers. And the easiest way to do that is just multiply the entire equation, both sides. Remember, whatever we do to one side of an equation, we must do to the other to keep it in balance. So this 3, we're going to multiply the entire equation by 3. Okay, so what I want to do, just to remind myself that I'm working with both sides, I'm going to put this 3 up here, and we're going to multiply this entire equation by 3. So 3 times y is 3y. 3 times 2/3 is going to be equal to 2/3 times 3, which is 2 times 3 times 3 and times x, right? And plus 4 times 3. Remember, we have to multiply. Let me unsqueeze that a little bit. Somehow that 4 didn't pick up the first time very well. Plus 4 times 3. Okay, and so now what do? We can kind of collect terms and see what we got. So 3y equals, and this 3 and that 3 will cancel. So we will have 2x plus 4 times 3 is 12. Okay, so we're getting there. Now what we want to do is get all the variables on one side. All right. So we're going to bring the x over to the other side. We're going to subtract 2x from both sides. Okay, and what we'll do is minus 2x plus 3y is equal to 12. Well, we're almost there. And notice we have all integers now. We have the variables on one side and the constant on the other. The one thing remaining here that we have to take care of is we have to take care of the fact that the a constant in the ax plus by is negative, and we need to be positive, right? So we're going to multiply again. We're going to take this remaining part of the equation, and we're going to multiply it by minus 1, okay? Yeah, unsqueeze that a little bit. I got a little too close. All right, times, we're going to multiply this by a minus 1. And where we end up is then minus 2x times minus 1 gives me my positive 2x minus 3y equals minus 12. Okay, now I am in standard form and it meets all the requirements. That the a term is a positive integer and 3y, the 3 of 3y and the minus 12 are both integers. All right. Now let's go the other way. Let's take a look at this equation. Now the strategy here is that we want it in slope-intercept form, which means we want it in a form of y equals mx plus b, right? So what we have to do here is we have to get y by itself first and then divide y by whatever coefficient it has in order to get it to be just plain old y, not 5y or not 6y or whatever it may be in the case where we start. So the first thing we're going to do in this equation here is we're going to first of all get y, the 5y, the negative 5y by itself. So how do we do that? Well, we're going to subtract 3x from both sides. So what we end up with is minus 5y equals minus 3x plus 15. Okay, now we see that we have negative 5y over here, so how do we make this y by itself with no encumbrance? What we're going to do is we're going to divide the entire equation, both sides, by minus 5. Okay, that means every single term has to be multiplied by, or has to be divided by, the minus 5. Okay. So what happens here? The 5's cancel, and we end up with y equals, and we have a minus 3 divided by a minus 5. That becomes a positive 3/5 x, and then 15 divided by minus 5 is minus 3. And that takes care of it, and we are done. Okay, so y equals 3/5 x minus 3. Now I want you to notice something here that is also extremely useful if you remember this little shortcut. Notice that the equation we end up has a positive slope here, right? And up here in the original equation, we have a plus coefficient for x and a minus coefficient for y, which is gives me, and so notice that when I have a positive negative, I actually end up with a positive slope down here. So that's one thing. If you have ax plus by and the b term is negative, you're going to end up with a positive slope. So that's the first thing you can look at. The second thing is if I'm checking a graph of an equation that's been plotted using standard form, the slope, notice what the slope is here. The slope value, this 3/5, can actually be calculated directly here just to check it as a over b, minus a over b, okay, which is going to be minus 3 over b, which is minus 5, which is 3/5, right? See how that agrees there, that you can calculate the slope of a linear equation that's in standard form by taking the a term, negative a term over the b term, and you get the slope. Okay, so that's just a little shortcut that will come in handy when you're plotting these graphs. All right, and that's all for that lesson. Look for the worksheet.